This is Intro to Proofs. We're doing Preview Activity 2 from Section 3.3. Genevieve, my little cuddle bug, is still with me right here. Still not quite ready if she's ready to sleep for the long term tonight. So we are doing Preview Activity 2, number 1, where we have a statement for all real numbers x and y. If x is not equal to y, then x over y plus y for x is greater than 2. Hopefully you're following along in your book right now, because that was a mouthful. So we want to find an example to show when that is false. Okay? A great hint to see what example might look like is look at number 2 and what added conditions are added. Number 2, where the added conditions are x is greater than 0 and y is greater than 0. So that's a good hint that I should use some negative numbers to find a good example here. So I'll try x equals 1 and y equals -1. In that case, x over y plus y over x equals 1 over -1 is -1. -1 over 1 is 1, is equal to -2, which is not greater than 2. Okay, so that's an example that shows that it's false. Okay, so let's look at number 2. So instead of word statement, we'll work with a related statement that is obtained by adding conditions to the hypothesis. Okay, what assumptions need to be made for the proof by contradiction for the statement? To do this, we need to negate the entire statement, including the quantifier. Okay, so we've got our, I'm going to write down the whole statement. So if x is not equal to y, and they're both greater than 0, x greater than 0 and y greater than 0, then x over y plus y over x is greater than 2. Okay. So let's see here. I want to prove this by contradiction. So assume that, so we're saying, with this statement right here, you could treat it like ands, or you could treat it as these are the sets that x is coming from and y is coming from. So I'm going to restate it. Well, one way to do it would be to restate it. Negate the entire statement, including the quantifier. Call it the negation of a statement in the universal quantifier, the statement that contains the existence. Okay, so the statement is false, then so if it's false, then there exists an x and y, an x greater than 0 and y greater than 0, such that x is not equal to y, so the hypothesis is still true, but x over y plus y over x is less than or equal to 2. That would be, give us the proof by contradiction. Okay. Carefully write down all assumptions made at the beginning of a proof by contradiction. Yeah, good advice. All right, that ends preview activity 2.